our last presentation, I have not the title, so I am requesting Professor Dewan Farid, you can start your presentation, giving your introduction as well.
Hello everyone, this is Dewan Farid from United Nations University. I'm working as a professor in the Department of Computer Science and Engineering. So the title of this paper is Agriculture 4.0 in Bangladesh. So machine learning and big data in precision agriculture. So mainly we'll try to talk about the challenges and issues, how actually we adapt these concepts, machine learning, big data in agriculture. Okay, so this is the presentation outline. So basically I'll talk about agriculture 4.0. So we'll start with industry 4.0 and its technology. Then we'll talk about the problem definition and motivation. So we'll very briefly present machine learning and big data to you guys, and then I'll explain a few models that will actually propose for this, like say for example, how actually we adopt these technologies in Bangladesh, and then the conclusion and future work. So agriculture 4.0 is 4.0 is basically the industry 4.0 in agriculture. Like, so this is the future technology for agriculture. So we can say also the precision agriculture. So what's the reason? Because of adopting agriculture 4.0, because we want to increase production, so minimize the risk and many things. Like that's actually say for example, like we want to actually amalgamate the precision agriculture. So you know, the industry 4.0, that's we have 9 pillars. So among them, big data machine learning is one of the key pillar in industry 4.0. So how actually we adopt this machine learning, big data concept in agriculture, that will be the main focus of this talk. So this is the revolution, from first industry to fourth industry revolution. Like in first industry revolution, actually we replace our hand with a water steam energy, and then the second industry revolution we actually replace the water steam power with electricity, and third industry revolution we actually introduce ICT in the industry, and finally the concept like knowledge mining, or the fourth industry revolution is like the concept of extracting knowledge from huge data, from the big data, like applying big data, machine learning, this kind of concept. So these are the technologies we have. So we these are the 9 technologies we have in the fourth industrial revolution. So big data is one of the main pillar here, and also to analyze big data we need to have the machine learning. So the main concept or idea is to apply these technologies in agriculture. That is called agriculture 4.0. So this is basically the agriculture 4.0. So now that we try to use the advanced technologies like robotic hands or robots or the drones, industry, Internet of Things. So it's not like the human or farmers, they are actually cultivating their crops. Like, so we use, so there are a few projects like entirely say the full operation is done by the machine. So even machine can actually collect the fruits. Like, is it like say for example the rotten, or is it okay? It's also the collect by the machine. So this is basically the agriculture 4.0. So here, this is the problem definitions. Like if you can recall your memory, even some parts of our country still we use the traditional technique. Like you see, this is a I don't know how it's called. So it's like in Bangladesh it's called langolo. You know, the cow, and this is pulling the things, and then this is the transformation. So now you see we use tractors to actually irrigate the crops. Like, so this is a transformation. But nowadays this is the technology. Like, we can predict many things. We can actually say for if you look at this year condition, like say for example the potato was it is a so the potato market, if you see, the farmers, they lose a significant amount of money because there's a huge amount of production. So when we have a huge amount of production, the price fall and the farmer basically suffer. So these things. But if the farmer can predict, okay, it will be like the price will be not that much for potato, then they can actually cultivate something else, like instead of potato, they can cultivate tomato, right? So this is the things actually we can actually use machine learning for forecasting. Even for this situation we have, still, the 2 weeks back we have a Citron. So every year we face some kind of natural disaster like the cyclones or the flooding. But if you can predict, okay, this year this portion of the area will be flooded, so they will not cultivate there. So this is that's the reason that actually we are thinking to apply this machine learning concept in agriculture. So this really, so all about the forecasting is about the climate forecasting, price forecasting. So this is actually that's why actually we need agriculture 4.0. So the motivation is like I added a simple quotation. So my presentation will be very simple. It's not that much difficult equations and things. So the quotation by Markman, like machine learning, deep learning, AI, whatever you are doing, if you don't understand it, learn it. Otherwise, you're gonna be a dinosaur within 3 years. It's a very interesting quote. So, and now you see, it's not like say even the rickshaw puller, they have their smartphone. If you see that even our farmers, they're very smart now. They can operate their smartphone. Even someone, they can also use their electronic device, like even the laptops. So it's not the say, for example, we cannot say that they are not that much educated to use this kind of device. They are really very much talented. Okay, so why we need agriculture 4.0? One of the things to contribute in our GDP, that's really important. So this I'm not taking too long things. I'm just skipping a few of the slides. So indeed, we need to ensure the foods and nutrition security, and also we need to actually increase our GDP growth. That's really important. And this is basically the basic process of machine learning. So in each process, actually, there's a lot many things to do for agriculture 4.0. Say, for example, normally we collect data from the field. So we use IoT or IIoT, Internet Industry of Things. So now there are some kind of sensor that can actually measure the water level or soil moisturizer. Even say, for example, even it can actually even it can take the picture of your field, and also it say it can analyze the leaf, like your field is affected by any kind of disease or not, something, right? So so data collection is very important. And then the second part is data processing. So data processing, like when we collect the data from any sensor or like any IoT devices, the first thing is to remove the noises. So pre-process is really important, data pre-processing, where we need to actually remove noises. We need to actually integrate the data, discretize the data. We need to transform the data. So there are some processes. So here we have also the EDA, exploratory data analysis. And then actually we try to build a machine learning model. So nowadays deep learning is really very popular. Even deep learning, we can use it for classification and regression tasks if it is a supervised learning. So most of the cases in agriculture 4.0, we found that it's a supervised learning problem. So we thought, okay, deep learning will be the very interesting one, but it's not always like to apply a very complex model. Sometimes actually we can use very simple model like decision tree or any regression technique. And then model testing, model deployment, and retaining models. So retaining model is really important because we don't know the after 6 months or over the time the performance of the model will be accurate or not. So it's really important to retain the model. So this is basic process that we need. We split the data into 3 chunks, like training set, test set, and validation set. So normally, some cases we don't need validation data. So we actually say, for example, some of the algorithms like decision tree or the support vector machines, you don't need to have a separate validation set. But if you want to build artificial neural network, you need to have a validation data. So this is a very common part in machine learning. So about big data, normally what I found in literature that the big data is basically 3V: volume, variety, and velocity. So the data should have these 3 characteristics. The volume should be very large. the data should be multivariate. So we may have the different types of features or different types of variables in the data, and velocity is streaming data. Data is continuously generating. So at least we have these 3 V's to have a big data. And what's the challenge for big data? First thing is to store the data. So data is too big. We cannot store the data into a particular single machine. So we need to have a data center, or we need to actually divide the data and store the data as a distributed file system manner. So the Hadoop is very common framework for big data management. So they are actually they use Hadoop distributed file system. And the second challenge is to process the data. So the data we have not in a single machine, in a different machines. So it is really difficult to process the data. That's why we need machine learning. So we need to have a parallel processing. And another challenge is like how fast we can process the data. So there is no alternative of machine learning to process the data. So in this paper, basically we try to propose few models that we can say, okay, these are the models that Bangladesh can adapt for agriculture 4.0. So first thing, how we can train our farmers. That's really important. So our farmers, they don't, okay, they are very talented, but maybe they are not too expert to say, for example, deal with some sophisticated machines. Like they can say, for example, they can't use the IoTs, or they don't know what is cloud computing, what is machine learning. So they need to have some basic understanding. So we need to train our farmers. So these are the basic things. Then we propose a model. So a framework has a physical layer, edge layer, and cloud layer. So physical layer is basically the collecting data from the field with the sensors or IoT device, and the edge layer is basically process the data. So this is data pre-processing steps, like if you have a noise, missing values, if you need to discretize, if you need to transform the data, if you need to integrate the data, that will be done at the edge layer. And the cloud layer is data in a cloud. So now you see the Google Cloud, iCloud is very popular. We can store the data in a cloud. So and this machine learning will be actually work on the cloud. So whatever the model that will actually build, that will analyze the data, that is the cloud part. So so this is the a framework, clusters-based knowledge transfer approach that actually proposed in this paper. Basically, I'm working on this from 2020. So this is like how actually we educate our farmer about Industry 4.0, how actually we introduce them to these kind of technologies. So the idea is to not to train everyone. We actually select who are the smart. Some of the smart farmers will consider them and will train them. So they will apply these technologies in real field, so that the other farmers, they can see. And if they actually, this is called learning by doing or seeing by doing. So when they will see, okay, his colleagues or another farmer actually applying this technique, he will be easily adapt the technique. So that's we say the cluster-based approach for knowledge transfer approach. This is the normal framework that actually I talk about, like physical layer, edge layer, and cloud layer. So we are collecting data from field using sensors. Then the edge layer basically doing the data pre-processing task, like data splitting, data, say for example, all these things like missing values, transformation, all. So basically the edge layer actually prepared the data for the mining, and the mining will be done at cloud layer. So all these models, AI model, machine learning model will be in cloud. So now you see some of the, say Google provide free cloud computing like Google Collaboratory, Google Colab. So if you can store the data in Colab or in a cloud, that is easily we can actually compute. So we don't need to have a very strong computational device. So basically we try to propose 3 models, one for crop, one for fisheries, and one for livestock. So this is basic model, and here we propose we can use deep learning, but it's not like you always have to apply a very complex model. If you want, you can actually simply use some probabilistic model like Bayesian classifier or distribution tree. So it actually collect the data, preprocess the data, and analyze the data. So the three-layer architecture or three-layer model. So this is for crop, and this is for fisheries, and this is for livestock. So this is very common. Like so, what I'm saying here is really difficult if we want to implement. So the implementation is totally missing in Bangladesh. We are talking about, okay, industry 4.0, a lot of many things, machine learning, big data, but real implementation is still missing. So we are far behind. So whatever the things, the conference is about here. So what we want to do, we want to see the smiles of these people. So they are actually the stakeholders that we want. So thank you very much. Thanks for your patience. I especially like to thank the chair and co-chair for allowing me to present my paper in this session. Basically, it was a yesterday's session. I was out of the Dhaka. That's why I was unable to present the paper. So my thanks, really, I really appreciate the consideration. Thank you very much. So these are some of the references. This is my paper that I published in previous conferences. So if you have any queries, please feel free to ask.
Thank you, Professor Farid. So any query or question from the audience? So Professor Farid, I have some observation. Actually, not actually about this implementation point of view, feasibility studies.
Not yet. So this is just like we are proposing the models. So we actually review the literature. So how actually the first world countries, mainly we try to focus the European countries. So how they actually adapt 4.0 agriculture 4.0 in their country, and based on their model, we try to actually propose some model for the Bangladesh.
Okay, thank you. Any piloting related issues? Actually, I think from the piloting is very important.
Right. That's why we are applying to the government. Even I'm working with them, Department of Agriculture Marketing. So so I'm working with them for about forecasting. So we are collecting data, and we are actually building a decision support system model. So it's the issue about piloting. Thank you. Please.
Thank you for a nice presentation. I'm Shahid Rahman. Question. We're facing a major problem in our aspect of in our country. Say, if you go to in our village, very root level, if a banana or 10 banana per banana.
It's about one each banana is 10 taka. Right. Okay, that's the real challenge, right? I got your question. So that's the real challenge that the Department of Agriculture Marketing they are facing. So there's some layer. So they actually getting more benefits. So in the supply chain process, if until you can break that chain, so the middleman they are actually gaining the more profit. So that is really important. But if we adopt the technology, so that what we can see, we can actually we can see the real price. The farmer can see, okay, I'm selling banana with 1 taka, but in super shop in Dhaka, each banana is actually sold in a 10 taka. So they can say, okay, why not? We can actually directly contact with the super shop owners, and how can we directly supply the product to the super shops? So that is the reason. So there is no alternative of using technology. I think you got your answer. So right, currently about in this paper, like what we are proposing, like a model that we can use the sensors. How can we process the data? How can we analyze the data? So this is a 3-layer architecture model. So we are proposing the model, like what you were saying to the prices, like to focus the price. We are not working on that. We are working on how can actually we use technologies to get say how can we increase our production. Well, that is the thinking. We are not focusing about the price, but your concept is really important. Okay.